Good afternoon. Can you hear me? Shall I start? Okay, so I had given you one paper, if you remember, for assignment. I'm taking questions from there. Okay. So we'll start with question number 1. What is Lorentz force? Okay, so suppose you have a charge. Suppose there is a charge plus. Suppose there is a charge plus q, and there is a magnetic field. Suppose there is a magnetic field here in this area, in this region. There is a magnetic field, right? Magnetic field is B. And now suppose, okay, let me just erase everything first. So you have a charge plus q moving with velocity v, right? Velocity is a vector. So we have a charge plus q moving with velocity v, and let us say we have a magnetic field also. We have magnetic field in this area. Suppose in this direction. In this direction we have magnetic field, right? Such that the angle between V and B is theta, right? So then a force will act on this charge particle, and that force is, the formula for that force is Q times V cross B, right? This is the magnetic force that will act on this charge particle, which is moving with velocity V, and the magnetic field here is B. Okay, understand? This is called magnetic Lorentz force. This is your magnetic Lorentz force. Okay, now suppose instead of magnetic field there is electric field. This particle is there plus q, but instead of magnetic field we have electric field, right? So instead of magnetic field we have electric field E, electric field E. Then the force on this particle F will be Q times E. This is the electric force on a particle whose charge is plus q, and the electric field is E. This is the magnetic force, this here is the magnetic force, this is the electric force. So that means if I have a region, where both electric field is there and magnetic field is there, then the total force on the charge plus q will be equal to this plus this. So, it will be q e plus q v cross b, right. And if I take q common, this will be q e plus v cross b. So, this thing is called the Lorentz force. This is total Lorentz force on a particle. Is it clear or not? Is it clear so far? Is it clear to everyone? Any doubts? What is Lorentz force? Is it clear? Okay, so again I will repeat. Suppose I have a charge plus q here, I have a charge plus q, right, and there is a magnetic field whose strength is B. Then this particle will experience a force because of the magnetic field, and that force formula is, the formula for that force is q times v cross b. This is the force on the particle which is moving in the magnetic field B with a speed v, right. So, v is the speed of the particle, b is the magnetic field, and the charge of the particle is q. Then it will experience a force this much. This is called magnetic Lorentz force. Now, if the same particle is kept in an electric field, right, this is an electric field and the direction of the arrow is the direction of the field, right, strength of the field is E, capital E, then this again will experience a force, and the force in that case will be q into E, q into the strength of the electric field. So, now suppose this particle is inside a region where both electric field and magnetic field is there, right, then this particle will experience a force because of electric field also, magnetic field also. In that case, the total force on this particle will be q into E plus q v cross b. From here I get q e, from here I get q v cross b. So, total force will become this much. So, this is called Lorentz force, and this is the expression also. This, see here the question is what is Lorentz force, write this expression. So, Lorentz force you can write the force experienced by a charged particle when it is moving through a magnetic field and electric field simultaneously, right. So, that is a Lorentz force, and the expression is q e v cross b. Is it clear now? Okay. So, now next question, what is Biot-Savart's law? I think you know this, I do not have to explain again. If you have a wire that is carrying a current I, and suppose I have a small element here, I consider a small element, small area you can say, or small, not area, sorry, small length. Suppose I consider a small length here in this wire. If I consider a small length in this wire here, dl, right, consider a small length dl, then this element will be I dl, this small region will be I dl element, right. So, according to Biot-Savart's law, the force at some point P because of this wire, suppose the distance is r, then the force on the magnetic force. So, you should know that if a wire carries current, it behaves like a magnet, right, behaves like a magnet. So, the force, the magnetic force at a point P at a distance r from the wire is, suppose angle here is theta, then according to Biot-Savart's law, a small force is equal to mu naught by 4 pi I dl cross r divided by r cube, right. So, this is Biot-Savart's law. This gives the magnetic field at a point P which is at a distance r from a current carrying conductor. Okay, any doubts? Biot-Savart's law is clear? Okay, mu naught, this mu naught is a constant. Mu naught is a constant, right? It is called the permeability of free space or vacuum. Okay, this is the permeability of free space or vacuum. It is a constant, and the value of this is, value of mu naught is 4 pi into 10 to the power minus 7. Units you can find from here, it will be Tesla per ampere meter square. Units of mu naught will be Tesla per ampere meter square. Is it clear what is mu naught? Right, this constant you will use when everything is kept in vacuum or free space or air, right? If your setup, this wire is in air, this vacuum, then you can use mu naught. But if suppose this is kept in some other medium, then this mu naught will be different, the value will be different. Okay, it will not be mu naught. In that case you will use mu. If your wire and the point is not in free space or vacuum, then you will not use this formula, you will use the formula mu by 4 pi I dl cross r divided by r cube. What is mu here? Mu here is mu naught into mu r. So mu naught I already told you is this one. Mu r is the relative permeability of the medium. Mu r is relative permeability. Okay, relative permeability. Is it clear? Of the medium. So if the medium you are keeping is in water, then there will be some value for this. I don't know the value for water, and similarly if you have any other medium, then the value will be different. Is it clear? R cube, because see this is the vector form. In vector form it will be r cube, but now suppose if I remove this cross, then I get here, I will just erase this, just a minute. Okay, so so I said dB is equal to mu naught by 4 pi I dl cross r divided by r cube. Why it's r cube? It's because we are using the vector form. If I remove the vector form, that means I will remove the cross. If I remove this cross, sin theta comes, so I dl r sin theta, right? In that case divided by r cube. Now this r, one r is here, one r is here, you can cancel, and then square will be left. Then the square part, actually this formula for magnetic field is directly proportional to 1 by r square. That is correct, right? Here I have put r cube is because it is in the vector form. If I bring it in the scalar form or with unit vector here, then r square you will get. Is it clear? Please, if your network is slow, you check, you find some other place in the home. Okay, I cannot do anything if your network is slow. Try to find a spot in your house where it works. Yes, any doubts? Is it clear or not? What about mu naught? Mu naught is clear. What is mu and mu naught, all that? Okay, so I will move on. Now, no force is exerted on by a stationary charge when placed in a magnetic field. Actually, this will be on, not by, on a stationary charge, right? So, what is the meaning of stationary charge? Stationary charge means not moving, right? A charge which is not moving. So, just now I told you, if I have a magnetic field B and there is a charge which is moving with a charge q moving with velocity v, then the force that it will experience because of the magnetic field is q v cross b. This is the force experienced by a charge plus q moving with speed v, and where the magnetic field is b. So the question says, why the force, why no force is there on a stationary charge when placed in a magnetic field? So on a stationary charge means not moving. So not moving means v will be 0, right? V will be 0 if it is not moving. So in that case, this force F will also be 0. Is it clear? Any doubts? Is it clear? Yes or no? Is it clear? Is it clear? Can I move on to the next question? Okay. So next question is, under what condition is a force acting on a charge moving through a magnetic field maximum? So again, force on a charge moving through a magnetic field. So force is how much? What is the formula? Formula is Q V cross B. This is the force on a charge q moving through a magnetic field B with a velocity v. So question is, when is it maximum? When will this force be maximum? Now this is in vector form. If I remove the cross, I will get Vb sine theta. If I remove this cross, right, this is from vector we have done in class 11. So the formula for force is QVB sine theta. So when will it be maximum? When this sine theta is 1. When the value of sine theta is 1, only in that case it will be maximum. So sine theta 1 means theta must be 90 degree. So the force on the charged particle will be maximum when theta is 90 degree. What is theta? Theta is the angle between V and B. If your charge is moving in this direction and B is in this direction, suppose this is your B and this is your V, this is 90 degree. So in that case your force will be maximum. Is it clear? So answer will be, the force on a charge moving through a magnetic field will be maximum when the angle between the direction of movement and the direction of the magnetic field is 90 degree. Is it clear, this one? Is it clear? Can I move to the next question? Okay, next question. Why is voltmeter always connected in parallel to the resistance in a circuit? What happens when it is connected in series? So I think I've given you how to convert how galvanometer is. How galvanometer can be converted to voltmeter, I have already explained. I have given the notes also. So if you have a galvanometer, suppose I have a galvanometer here, then if I connect a high resistance to this galvanometer, then this thing will behave like a voltmeter. I hope you know what a voltmeter does. A voltmeter is used to measure the potential difference, voltage. Voltmeter is a device that measures potential difference or voltage across two ends, right? So how to convert galvanometer to voltmeter? Connect a high resistance in series with the galvanometer, you will get a voltmeter, right? So the question is, why this voltmeter is connected in series, in parallel? So why do we connect it in parallel? So the question is actually, so this diagram here also is the same thing, right? I have attached this diagram here on the right side, if you can see, right? So this here is the voltmeter, galvanometer with a high resistance. This is a voltmeter. So the question is, suppose I have a circuit here, resistance, this is the symbol for voltmeter here, voltmeter, right? So the question says, why do we connect this voltmeter in parallel with the resistance? You must have seen this. Whenever you make a series, whenever you make an electrical connection, voltmeter is always connected in parallel with the resistance. So why do we do this? The question is, why do we do this? Because if you want to measure the voltage across two ends here, this end, across this end and this end, then minimum current should flow, minimum current should flow through the voltmeter if you want to measure the potential difference between these two ends. Minimum current should flow through the voltmeter. So that's why if you connect in parallel, what will happen, the current will start from here, it will go from positive direction, because this is a very high resistance here, this V is very high resistance, so the current goes straight, does not go through this path, right. So that's why you can measure the full potential difference. Okay, but if you connect in series, what will happen, if you connect this in series instead of parallel, suppose you connect it here instead of here, then what will happen, the current will go here also, it will go through this path also, then current will pass through this point also. In that case you cannot measure the potential difference. Is it clear?
बिन पनि लिनु थियो तपाईँ बिन लिएर आउनुहोस् माथि प्लास्टिक थियो के त्यो बिन लिनको कन्फ्युजन
Okay, next question. So what is magnetic Lorentz force? I have already answered this question. Give its expression. Magnetic, when if the question is only about magnetic, then the answer will be Q V cross B. We will not include this part. This part is not included because it's only magnetic, so only this part is included. When it is maximum, I have already told you, because this expression is Q V B sin theta, it will be maximum when sin theta is 1, right, maximum, and it will be minimum when sin theta is 0. Okay, so when will sin theta be 0? When your theta is 0 degree or 180 degree, right. So maximum I have already explained why, when is it maximum. So I'll just explain about minimum. Suppose your particle is moving in this direction, right, particle is moving in this direction, and your magnetic field is along this direction. In that case the angle between these two is 0. So if you put sin 0 degree here, this will become 0, so force will also become 0. So this is one way where the force will be minimum. Another way the force will be minimum is if your magnetic field is in the opposite direction, right. If it is in the same direction, it will angle will be 0, but if it is in the opposite direction, angle will be 180 degree. So if you put 180 degree here, again sin 180 degree is 0, so force will be 0. So that is minimum. Okay, maximum when the angle is 90 degree, minimum is if the angle is 0 degree or 180 degree. Is it clear? Is it clear, yes or no? Okay, let me repeat this again. So, first question is, what is magnetic Lorentz force? I have already answered this question in the one of the last questions. So, the formula is Q V cross B. This is the magnetic Lorentz force. If you have a magnetic field B and there is a particle moving in this magnetic field whose charge is Q and velocity is V, then the force on this particle will be Q V cross B, right? This is the magnetic force. Let me write M for magnetic. Okay. Now, if I remove the vector here, I will get VB sine theta, right? I am just writing the magnitude. This is just the number. Direction, we are not concerned with direction here, right? Okay. So, Q VB sine theta is the magnitude of the force. This will be the amount of force that the charge will experience. Now, see, the question is, when will this be maximum, when will it be minimum? So, maximum or minimum depends on sine theta. Okay, whether it will be maximum or minimum depends on the value of sine theta. If sine theta is equal to 1, then force is, then Fm, force will be maximum. Okay. Now, when will sine theta be 1? When theta is 90 degree. And what is theta? Theta is the angle between V and B. So, this angle here, right, this angle in this diagram is theta. Okay. So, when this angle is 90 degree, in that case your force will be maximum. Okay. This also I have answered in the last question, but now the main answer that we have to answer here is, when will it be minimum? So, for minimum, if so for minimum, sine theta should be how much? Sine theta should be 0. Okay. The force will be minimum if sine theta is 0. Now, when is theta 0? Theta will be 0, sine theta will be 0 when theta is 0 degree or 180 degree. Okay. Now, what is the meaning of 0 degree? 0 degree means both the particle and the magnetic field are in the same direction. Magnetic field is this and this is your particle. Okay. Understand? In that case, your angle between V and B will be 0 degree. So, your force will be minimum. Now, another way this can be 0 is if they are in opposite direction. If your charge is going in this direction, right, and magnetic field is going in the opposite direction. In that case, what is the angle between these two? Angle is 180 degree. So, again, if you put sine 180 degree here, again it gives you 0, force will be 0, minimum. Is it clear now? Okay, next question. State and prove Ampere circuit law. This one I will not do. This I have already given you the notes on this, right? You know Ampere circuit law. Line integral of magnetic field B is equal to mu naught times the current, right? So, if I have a circular area, not circular, any closed area which carries a current I, right, then the line integral, that means if you integrate this term B dot dl along the surface, along the length boundary, then the formula is mu naught I. I have already given you this, and proof also I think I have given. Yes, I think this is clear. Right, Ampere circuit law I don't have to explain, right? So Ampere circuit law, so what does the Ampere circuit law say? The line integral of magnetic field around a loop is equal to mu naught times current enclosed by the loop. Okay. So according to this, what the law wants to say is that suppose I have a wire here, it carries a current I, right? So around this wire I can make a closed loop, right? It can be of any shape, does not have to be a circle or whatever. It has to be a closed loop. Closed loop means which meets in the end, right? This is a closed loop. This is not a closed loop. It does not mean, right? So it has to be a closed loop. So according to Ampere circuit law, if I find the line integral means when you integrate along the boundary, right? This is called line integral. You have something like volume integral, surface integral. In case of surface integral, you integrate along the surface. That means you add all the terms in the surface. Here you will add the small this value, right? You will find this value at this point, maybe then this point, this point, this point, like that, and you will go on adding, right? So according to Ampere circuit law, the total will be equal to mu naught into the current. What is the current that is enclosed? What is the current that is enclosed by the loop? I, right? So this is the formula. Is it clear or not? So this is the law, and we can use this to find magnetic field because of different systems. If I have a solenoid, if I have a toroid, I can use this to find the magnetic field. Is it clear now? Okay, next question. Explain how a circular current loop behave as a magnetic dipole. This also I remember I have given you the notes that suppose I have a circular loop like this, right? And this loop carries a current I. Okay, this loop carries a current I. Okay, then remember I told you that if the current is flowing in the clockwise direction, then this part will behave like south, right? And similarly, if the current is flowing in the anti-clockwise direction, if it is flowing in the anti-clockwise direction, then this part will behave like north. So that is the question. Okay, why does it behave as north, why does it behave as south? So first thing that you have to understand is any wire that carries current behaves like a magnet. So even this behaves like a magnet, but why does this behave like north, why does this behave like south? That is the question. So in that case we have to find, we have done this. In fact, if you check the notes, first what will you do, you'll find the magnetic field. How to find the magnetic field? First you'll need to find the area, right? So formula is like this, m is equal to Ia. This is the magnetic moment, right? You have to find the magnetic moment first. So how to find this? If I is the current flowing through the loop and A is the area of the loop, then magnetic moment will be I times A. So for that we need to know the A. Suppose the radius is r, area will be pi r square, right? So the magnetic moment will be this I into pi r square. Okay, understand? Now using this we can find the magnetic field also. So let us try to find the magnetic field. Just a minute, I'll just show you this. Do you have the notes, this one derivation for this with you? Yes, do you have the notes with you, that one that I just showed, this one? Do you have the notes for this? I think I have given that if I have a current I flowing through this wire, then magnetic field B at point P is how much? Do you have those notes with you? Okay, so right, so I think in that you find this one, right? This is the, if you can see, right, this is the magnetic field at a point at a distance which is at a distance x from the center of the coil. Then this is the magnetic field. That means at a point P, right, at a point P the magnetic field B will be mu naught n I a square divided by 2 a square plus x square to the power 3 by 2. So this is the magnetic field B at a point P. This part is clear? Okay, so that is the, I think that is the formula in your copy also. Just confirm that. Okay, this is the, this should be the formula there also. So using this, now look here. So we will use this formula in this explanation. Let me just erase. So yeah, so suppose again this loop is carrying current I, then the magnetic field B, suppose I keep some iron piece here, then this iron will experience a magnetic field B. And what is the magnetic field B that it experiences? Just now we have found it is mu naught I a square divided by 2 x a square plus x square 3 by 2, right? This is the magnetic field that this piece will experience here. Now suppose this distance is very small, this is actually x, this will be x and this will be a. Okay, this is your a area, the radius, and x is this distance. Okay, so in this formula a is this one, x is this one. Okay, I is the current. Okay, so now suppose x is very small, then you can ignore this x square, right? You can ignore this x square and your formula will become mu naught I a square divided by 2a cube, right? In that case this will be the formula. Now I a square, what is I a square? I a square is m, right? Just now I have shown that, right? Because what is magnetic moment? Magnetic moment formula is current into the area. So area is a square, because this is a circular loop, so it will be pi a square in fact. So I can put pi here. So this pi I'll include here and this will give me m, so I'll get pi here down also. Okay, so you can see that this circular coil will have a magnetic field that is coming out, right? That will come out of the area. So in that case this will behave like a north. Okay, direction, ignore the direction for now, but okay, I think this will become very complicated if I explain here. I'll take a separate video on this. Okay, I'll just make a separate video on this, otherwise it will be very complicated. Is it okay? Okay, so I'll move to the next question. Okay, because that becomes very complicated. Next question, yeah, this one, this is the next question. So what is the question? The question is, a circular coil of wire of 100 turns each of radius 8 centimeter carries a current of this much. What is the magnitude of the magnetic field at the center of the coil? So we have a circular coil which has 100 turns, that means 100 times the wire has been circled like this, right? 100 of times, right? So number of turns is 100, that means your n is 100, small n is 100. Okay, then what is that? The radius is 8 centimeter. Radius is denoted with the small letter a, so a is 8 centimeter, but you have to convert to meters. This will become 0.08 meters. Okay, that is the radius. What else is given? Current is given. Current is 0.40 ampere. So question is, what is the magnitude of the magnetic field at the center, right? If you look at this diagram, they are asking what is the magnetic field at O. Is it clear? So if I want to find at O, then x will be 0. Yes or no? This part is clear. X, how x is 0, is it clear? X equal to 0, is that part clear? Okay, again, so the question is, find the magnetic field B at the center of a coil, right? At the center, so that means at this point marked with green. Let me mark with green. They are asking us to find the magnetic field B at this point, and such that the area, the number of turns here is 100, the radius is 8 centimeter, and the current carried by this coil is how much? 0.40. So I need to find a formula for the magnetic field B at the center. What is the formula? How to get the formula? To get the formula, I will use this one. To get the formula for the center, I will use this one. Now see, this is the formula for the magnetic field B at a point P, which is at a distance x, right? If you look at this diagram, if you can see the diagram, let me just zoom in, right? If you look at this diagram, see this this formula, this here, this B here is the magnetic field B at point P, right, which is at a distance x. Okay, so if I want to find out the magnetic field B at the center, I will use this formula only. What will I do here? I will put x equal to 0. because at the center x is equal to 0, right? At the center x is equal to 0, yes or no? At this point x is equal to 0. Now is it clear? Is it clear now or not? Okay, so now, so if I put 0 here, look, if I put 0 here, what happens? Mu naught n I a square will not change because it is the radius, right? Only x will be 0, so answer will be, so if I put 0 here, this will become a square plus 0. I will not write the 0, and 3 by 2, so 2 cancel, a cube, right? So answer will be mu naught n I a square by 2a cube. So a square will cancel with a cube, so answer will be mu naught n I a by 2a. Is this clear how this formula comes? How mu naught, how the magnetic field B at the center is mu naught n I by 2a? Is it clear how the formula comes? Yes, so if it's not clear, just tell me frankly. Don't just nod or say yes. Is it clear or not? Yes, please say quickly. Okay, so now we will use that formula directly in the question. Okay, let me erase. So I'll erase this part. So now what is mu naught? Mu naught I already told you, 4 pi into 10 to the power minus 7. N is the number of turns. Number of turns is given is 100. And now I is how much? 0.40 divided by 2, and there is a is the radius is 0.08. Okay, so now cancel things here. So if I cancel here, 0.10, 0.02, right? Okay, so now 4 pi here, this will become 4 by 100, right? The denominator 2 into 0.02 is 4 by 100. I think maths part you will do by yourself. Now see, 10 to the power minus 7 and 100, so this will give me 10 to the power minus 5, and then there is one more, so this is 1 by 100, right? 0 point or okay, 0.10 is 1 by 10, you can say. Okay, this maths part, don't worry about the maths part, you will be able to do. Okay, now so this will become pi, and this 100 will go up, so it will become 10 to the power minus 5 plus 2 minus 1. So answer will be pi into 10 to the power minus 4 Tesla. Okay, maths part you will be able to do. Just tell me whether you understood this or not. How this formula we got, do you understand this or not? Yes or no? Is it clear their answer or what? Why is R 100 instead? It should be R is not 100. R is not 100. That is N. Okay. This is N, not R. Sorry if it looks like N. This is N. This is N, not R. Okay. And there is no R here. Radius is denoted with A. Radius is written with A, and N is the number of turns. Okay, is it clear? So now I'll go to the next question. Now this one, the question is, a long straight wire carries a current of 35 ampere. What is the magnitude of the field at a point 20 centimeter from the wire? Okay, so you have a straight wire and the current in this wire is 35 ampere. Question is, what will be the magnetic field B at a point which is 20 centimeter from the wire? So let us say the point is P and this is at a distance of 20 centimeter from the wire. So what will be the magnetic field B at this? So I think I have not given you this one, okay, but just you can just I'll give you the diagram later. Maybe this is the diagram for that. Okay, I did not do because this is not in the syllabus, but in CBSE they have done. Okay, so the formula for that is B is equal to mu naught I by 2 pi A. Okay, this is the formula for the magnetic field because of a straight wire at a point A from the wire. Is it clear? Is it clear? The formula is clear? What is B vector there? B vector is the magnetic field. B vector is the magnetic field at the point P, which is at a distance A from the wire. Okay, so now simply you know the formula now, put the values, you'll get your answer. So B is equal to mu naught I divided by 2 pi A. A is I is given 35 ampere and A is the distance from the wire to the point. Distance is 20 centimeter, put it there. So mu naught, you know, is 4 pi into 10 to the power minus 7. I is 35. Now divided by 2 into pi into A. A is how much? 20 centimeter, but we have to convert to meters. So this will be divided by 100. Okay, so 2 pi will cancel with 4 pi and you will get a 2 here. Now this 20 will cancel with 100 and you will get a 5 here. This 5 will go up. So 5 into 2 becomes 10 into 10 to the power minus 7 into 35, and answer will be in Tesla. So how much you will get? So this 10 will cancel with 1 7 from here, so it will be minus 6. So 35 into 10 to the power minus 6 Tesla, or you can also write 3.5 into 10 to the power minus 5 Tesla. This is the answer. Is it clear? Maths part. Is it clear or not? Is it clear? Can I go to the next question? Okay, next question. Same question, this one also, right? A long straight wire in a horizontal plane carries a current 50 ampere in the north south direction. So you have a wire, this is north, this is south, and the current is from north to south. So this way, what is the current? 50 ampere. Give the magnitude of the magnetic field B at a point 2.5 meter east of the wire. So they are asking you to find the value of the magnetic field B at a point which is at a distance of how much? 2.5 meter east. So this is east, right? North, east, this one. Okay. So they are asking you to find what will be the magnetic field B at this point. So very simple, same formula. So B will be equal to mu naught I divided by 2 pi A. So put it again, 4 pi into 10 to the power minus 7. I is 50. 2 in 2 pi, and area is not area, sorry, the distance is 2.5. So again 2 pi, 4 pi, you'll get a 2 here. Now if I remove this point, then divided by 10, this 10 will go up. So 25 will cancel with this, we'll get this one here. So 2 into 2, 4, 4 into 10 to the power, now minus 7 and plus 1 here, so minus 6 Tesla. So this is the answer. Yes or no, is it clear? Maths part I think you can do, just try to understand how the formula comes and all that. Which part explain again? Which part are you asking me to explain again? Yes, which part are you asking me to explain again? What about the others? Is it clear to you, or still doubts is there? Okay, so I'll go to the next question. If you are having any doubts, you ask. Okay, so next question. A closely wound solenoid 80 centimeter long has a 5 layers of winding of 400 turns each. The diameter of the solenoid is 1.8. If the current carried is 8 ampere, estimate the magnitude of B, magnetic field inside the solenoid near the center. So I think you all know what is a solenoid. It is a wire that is in this form, right? This is a solenoid, and we have also found out what is the magnetic field inside using Ampere circuitry law. So if you remember, the magnetic field inside a solenoid is mu naught Ni, where mu naught again you know is a constant. N is the number of turns per unit length, that means divided by total length. So that is N, and I is of course the current that the solenoid carries, if I is the current. Okay, so then the magnetic field B inside the solenoid, no matter at what point, it will be mu naught and I. Okay, whether it's center, side, whatever, it will be same. Okay, so question says that there is a solenoid and it has 5 layers. That means one wire is there, on top of this another wire. Okay, on top of this another wire, like that. Okay, and on top of this another wire again. Okay, like this, 5 layers, 5 types of wires you can say. Okay, 5 layers, and the number of turns in each layer is how much? 400. Okay, so how many turns are there total? 5 into 400. For each layer of the solenoid there are 400 turns, and since there are 5 layers, so 5 into 400. So total number of turns, so total number of turns is how much? 5 into 400. 5 into 400, this is equal to 2000. Is this clear? Total number of turns is clear or not? Rest of the things I think is very simple. Just try to understand this total number of turns. Five is a number of layers. 5 is the number of layers. So instead of using a single wire, you can say they are using 5 types of wires. Okay, 5 types of wire, right? So I'm showing you with different colors there, but just imagine that there are 5 types of wires. Okay, so you have wire 1, so wire 2, wire 3, like that. Okay, wire 4, and then one more wire 5. Okay, like that. So 5 different types of wire, and then they are combined to make a single solenoid. Okay, like that. Understand? So that means 5 layers. Okay, so that 5 is the number of layers. Is it clear? Okay, so now rest things is just putting the value. Now see, total number of turns is how much? Total number of turns is 2000, right? So you first you have to find the value of small n, because we don't know. So total number of turns is 2000. Now total length, what is the total length? Length is 80 centimeter. 80 centimeter, we have to convert to meters, so divide by 100. So now this 0 and this 0 cancels, this 10 will go up, so you will get 2000, one more 10, so divide by 8, so 82500. Okay, so if you cancel, you will see, you will get this. Okay, is it clear? So now you put here, let me erase this. So mu naught is 4 pi minus 7, n is 2500, and I is how much? 8. So now you find this, you will get your answer. Okay, 2 zeros will cancel with here, so this will become minus 5. So 8 into 25 is 200 again, so again 2 more zeros will cancel, so this will become minus 3, and what will be left here? 8. So 8 pi into 10 to the power minus 3. Maths part you will do, okay, by yourself, so don't worry about how I am getting 8 pi this one. Just understand that how this formula comes, how n is this much, I you know, mu naught you know, so just try to understand that. Maths part I think you can do by yourself. Okay, is it clear? Okay, next question. A square coil of side 10 centimeter consists of 20 turns and carries a current of 12 ampere. This coil is suspended vertically and normal to the plane of the coil. And normal to the plane of the coil makes an angle 30 degree with the direction of the uniform magnetic field of the magnitude 0.80 Tesla. What is the torque acting on the coil? So the question is, so this is the, so if you remember, we have done this one also. If you have a coil like this, PQRS, right? If you have a coil PQRS, just increase the size, right? If you have a coil PQRS this way, and suppose there is a magnetic field B, acting in this direction, right? Can you see? Then this coil will experience a force, and that force will make the coil rotate. It is called torque. Okay, if you have a if you have a coil which carries a current I, right, this I is the current carried by the coil, and this coil is placed in a magnetic field B, then this coil will experience a torque which will make it rotate, and the formula for that torque is M cross B. Do you have, I think you have the notes for this. Yes or no? Yes or no? Okay, so it's simple, we just have to find the put the values here. Okay, so what is M? I already told you is the magnetic moment, and what is the formula for M? M is equal to I into the area of the loop, and if the number of turns is more than 1, then the formula will be NIA. N is the number of turns, I is the current in the loop, and A is the area, right, and B of course is the magnetic field. And see, there is a cross product here, so if I remove this cross, I will get MB sine theta. What is theta? Theta is the angle between B and the area. Okay, theta is the angle between magnetic field B and the area. All that is given. So instead of M, I'll put NIA B sine theta. Is this clear? Yes or no? Is it clear? Okay, so now just put the value there. What is N? Now if you read the question, as number of turns is 20, so that means N is 20. I, what is the current? 12. What is the area? Since it is a square, right, the question says a square coil whose side is 10 centimeter. So if side is 10 centimeter, you know area of a square is side square, so it will be 100, right, but this is in centimeters, so you have to divide 2 times by 100 and 100. Okay, okay, side divided by 100, this will give me in meters. So now if I multiply 2 times to find the area, this will become 10 into 10, 100 divided by this one. Okay, and B is also given. How much is B? 0.80.